Hi, I'm Manoj Chiba and I'm presenting the course in Introductory Numeracy. A University of Pretoria team and myself from the Gordon Institute of Business Science have put together a series of online workshops that will aid your understanding of numeracy. The course consists of online videos, examples of each concept that should help embed the theory, and a test at the end of each section so that it serves as an acid test of how well you have grasped the concepts, which we hope will add to your confidence with numbers. The videos and content are aimed at building the following for each individual: a conceptual understanding of foundational numeracy, remembering a solid foundation is the key to success, basic numerical functions, construction and deconstruction of simple and complex equations. I find that we deal better with words than we deal with numbers, so let us stick to our strengths. The use of graphical and tabular methods, which will allow us to read and present information in a clear and concise manner without any ambiguity. The question I'm often asked is, why is numeracy important? Firstly, numeracy is more than just mathematics. It's pervasive and infiltrates everyone and every aspect of our lives. Secondly, it allows us to develop a confidence and competence with numbers and measures. Thirdly, it's really about understanding how information is presented in different formats and what it means. Some of the formats we deal with are graphs, diagrams, charts, and tables, which are really present everywhere. Fourthly, and most importantly for me, it's about analytical thinking, the ability to make logical choices in our everyday lives. As we have just heard, numeracy is about analytical thinking, of which numeracy is one example of analytical thinking, and this is rooted in the ability to make logical choices. What this means is really about how we think about how verbal and numerical statements are made. One example of this is statements of if and then. This translates into if the premise is true, then the conclusion is true, but not the opposite. Let us look at an example. In a contained situation, if someone is a mother, then we can conclude that they are female. However, the opposite, which states if female, then mother, simply means that all females are mothers, which we know is not true. All we really need is to find one female that you know or meet that is not a mother. Let us look at another example. The factory has been instructed to produce a deck of playing cards, which follow a simple rule. If there's a vowel on one side of the card, there has to be an even number on the other side. Here are 4 randomly drawn cards from a deck produced today: A, K, 4, and 7. For efficiency's sake, you now want to turn as few cards as possible to test the deck. Which cards do you need to turn as a minimum to confirm the deck adheres to the rule? Here are the 4 cards again: A, K, 4, and 7. Which cards would you turn? Please spend a few seconds completing it. You may pause the video here now. So which cards did you turn? A? Yes, that would be correct. A is a vowel, and therefore we need to check if the other side of the card has an even number. Here we are really testing the rule. K? No, there is no rule for non-vowels, so would not turn this card at all. 4? No. Turning the 4 would equate in saying that all females are mothers from our previous example. 7? Yes, here like the A, we are confirming the rule. That is, if there's a vowel on the other side, our deck does not adhere to the rule.